Okay, thanks for that introduction. And hopefully, I know it's that afternoon slump, but hopefully we'll go on a journey together. I'll try to finish 5 minutes before, so just that if there's any questions from the audience, we can actually go through some on that one. You can see I'm a teacher, so I like when people ask questions because then it gets us to better understand each other. All right, so yes, thanks, Mr. Pelele. I said I'm from University of Pretoria. But what's interesting here is I've co-founded this grassroots AI organization called Deep Learning Indaba in 2017, and then a second one called Masakhane in 2019 that specifically looks at AI in African languages. So we do a lot of work within those spaces, and I also then a co-founder and CTO of Lelapa AI. So I spent this morning at our offices in Rosebank at Lelapa, and then the rest of the time, for other 4 days a week, I'm at the University of Pretoria. This is our lab at the university. We have about 40 plus members now. 70% of them work on AI in African languages mostly, and then 30% work on this part that we call data science society. So how do we get AI and data science to actually be used by people who are not us? Right, so it takes into account regulation, understanding users, understanding the societal issues that are out there, and then figuring out how to get those things on there. So today, let's take a bit of a journey. We'll go through setting up some groundwork, thinking about the spaces that impact and the audience are in, and then going through, hey, what's the future within these spaces on the African continent? So on there. So we'll do some myth busting, some demystifying, and then AI for ***, right? And then we'll learn about the African AI landscape within this area. Because sometimes people think like there's nothing much that's going on. I'll say there's a lot that actually is going on. So why is data science everywhere right now? One, computing is cheaper, right? If you go back, depending on your age, thinking about the first time you interacted with something that was like a computer, right? Even if it's a cell phone, the first early cell phones or anything that was almost a mechanical computer that you had to use. They were big, didn't have a lot of storage, were very slow. And then now you think just about most people's TVs these days probably have more memory than what you had in a computer in the year 2000, right? So things have changed a lot on there, right? So storage is very cheap. And then you also have the internet. The internet then has brought up this lots and lots of human-generated content, right? That gets it through that, right? So because we're creating that content, it's thought. Then there's this part of what do we do with it, and that's where now there's opportunity, right? In the same way, if you can think about running a factory today, there's a lot of sensors that you have, a lot of things that you're collecting data. What are you doing with that data? Right, to add to your competitive advantage in one way or another. Okay, am I stuck? Right, yeah. But then there's this question that you'll hear, data science. What is data science? So it's really a mishmash of different things. So in the past, you would have somebody being a mathematician, somebody being a statistician, somebody being a computer scientist, an engineer, a subject matter expert in packaging or something like that. But what has happened is that there's people now who really what we call T-shaped. They have a breadth of skills and then also have a depth in one space. So they might come from stats, but then work within these other areas as well. And that's where then we use this Venn diagram of you've got a mix of skills that come together and you have these people who are called data scientists, right? But typically the way to think about it that's much easier is a process where you're going to have a problem. It can be business, society, science, whatever. Then you want to use data to be able to assist you in actually solving that problem, right? So you're going to have to collect the data or acquisition. You have to pre-process it, clean it, put it in the same places, integrate it into different things. You do modeling, analytical modeling. That's where your mathematicians, statisticians, your computer scientists, what have you, physicists even, come in that analytical modeling. You validate if you actually answer the question that you had at the beginning, and then you present or you deploy, right? Meaning that you now make decisions on within that. So this is a good way to think about problems, that you have this data process that you need to follow from beginning to end, and then it helps you in answering some of your very pressing questions in your organization on there. Then the other thing is then thinking about artificial intelligence, right? So I'll give a view also in there. So first, as I said, we lay the foundations. What's AI, right? What's artificial intelligence? So classical definition, an agent exists in some environment, it takes an action to achieve some goal. What does this mean? That's one of my daughters at our house, at our home. She's looking at our robotic vacuum cleaner that's in the house. That is a machine. It exists in our house. That's the environment. It can take action. It can move around. It can vacuum. And the goal is to keep the house clean. Right? So that's an artificial intelligence. You use a search engine. Search engine, it exists on the internet. You type in a query in that search box. It goes into its databases. Right? That's the actions that it can do. It identifies documents. And then it returns the documents to you. And the goal is to make sure it returns the relevant documents to you. That's an artificial intelligence, right? And you will hear then this sometimes mixed up with the word machine learning. What's machine learning? Machine learning is a subset of AI that specifically deals with machines learning patterns from data. What's this now? So let's say we've got a simple flat surface or a plane. You have two data points that are given to you. One of these data points we color red, and then the other one we color blue, and we say those are the labels. Right, that's what we call it. That's the labels are kind of on there. Now I ask you, if I was to drop a new data point without a color, what color is it supposed to be? You want to predict. You have to use the data that was given to you before to now guess what the next color is supposed to be. The easiest thing then is to identify what you call a decision boundary. In this case, it's actually just a simple straight line, y is equals to mx plus c, that sits in between, halfway between the 2 points that you had as examples before. Anything that gets dropped on the left in the future, I will predict that is red, and everything that gets dropped on the right of that line, I will predict that it's blue. Sure, this is a very simplified example, and the world is much more complex than that, but let's increase the complexity of our data. There's our second data set that we have now. In the same way, what tends to happen is that if you have more complex data, guess what happens? Your decision boundary itself becomes more complex. So instead of a straight line, the y is equal to mx plus c, you have now a more squiggly line, which is could be a quadratic function. So you have x squareds there, you've got x cubed that are in there, and then it fits the data. And in this one, you just split it. Anything that is above that line, I'll predict that is blue in the future. Anything that gets dropped below that line, I'll predict that it's red. So that's machine learning, specifically supervised machine learning, because you've shown the data point and also shown the color, which is the output that it's supposed to be on that one. And really, we can make the jump to your modern cell phone. Your modern cell phone, you have these things on your phone now where you can go into your gallery after you've taken pictures, and you can just type the word tree, and it retrieves all these pictures that have trees on your phone that you took on there. How did that happen? The same way. People have spent lots and lots of time collecting data, labeling images with lots of different objects, and then they train these machine learning models, specifically deep neural networks, these very deep models that then figure out these decision boundaries, and that's how you get to machine learning that's running on your phone today. Right? So you can take your picture, and then your phone identifies objects that are inside that picture, and then you can just type in words on your phone gallery, and then you get those pictures back on there. And in this one, it's just an example that it goes through that image, and then it identifies that there's a dog instead of a cat in the image. Why machine learning? Before machine learning, programmers had to sit there, explain the whole process of what's the data that's going to come in, what is it going to look like, how do you actually then come up with a dog? A dog will have a snout, it will have ears, it will have a nose that looks like this. It has to have maybe sometimes four legs. Some of them have 3, some have 2. It has fur like this. Just imagine, all these things would have to be described to the machine in one or specific way. With machine learning, you just feed the data. And the more data you feed, the better the models become. Right? That's why we're going through this revolution. What did I say at the beginning? Computers become very cheap, and data has expanded a lot. Right? And that's why we're having kind of these revolutions that are happening now, these things are happening in the background. You don't even get to see them. You just see a new feature being added, you use it. Right? What's happening is that there's people who are building these things on the other side, right? And there's been lots and lots of things that are going on up until the field is moving and how many ideas are being put out there and all those things. But as I said, most of them will actually not really survive, but that's how you build science. That's how you build innovation going into the future. What can you do? Here's some work that's coming out of some friends. For example, in Uganda, you can help farmers do things like identifying diseases on cassava leaf, right? So what happens is that now you can build a machine learning model, you put it on their phone, they take these phones, they have this very nice device that makes sure that you can put it very steadily, and then they've put the leaves under there, and it tells the farmer what disease might be affecting the plant. Right, so just imagine that, and that is being expanded. People are doing things like dermatology. You can look at skin and see if there's a lesion, and then try to predict and say, okay, with this, please go see a doctor because it's not like, it might not be benign. On there. At CSR, when I was there was some work that's being done on the left on identifying things like driver drowsiness. So this, again, once it becomes and it reaches mainstream, it just becomes part of the background. You don't notice it. So if you have some cars already have this. Right, and they will notice you, and then once you start looking like you're drowsy, you'll automatically start beeping and saying you should take a break. Right, on there. And then we've done some work I had with my master's student at the time, where she was working on identifying how accidents happen in towns, identifying kind of what the characteristics of towns are in terms of the layouts, where the streets are, where you can then predict that this area is likely going to have problems with a car accident in the future. Right, by using past data to do that. So what are these opportunities? Oh, hopefully I'm not going too fast for the audience here. So AI-driven material science. So we used to work at the CSR when I was there before on doing things like anomaly detection or novelty detection. So a lot of people are looking at the moment into, can you create new materials using AI? Right. The current way that material science is done in a lot of ways is that somebody sits in a lab, comes up with a new substrate in some way, and then you have to go through testing, and you don't have you don't have a lot of options because it costs you every time you have to create the substrate on there. But then with artificial intelligence, as I said, and with machine learning, you can learn patterns from the past and then try to predict the future. What does this mean? You can take a lot of experiments that other people have done before about creating some type of substrate on there, and then try to say, okay, now that I've built a machine learning model that says I'm now going to create, make a update on the way that we make paper in a specific way with new inputs, new chemical process or whatever. Now run, instead of testing in the lab at the beginning, you create all those characteristics, what your input is going to be, you feed it into the machine learning algorithm, then it predicts the types of characteristics that the material is likely to have. Then you choose only the ones that have the characteristics that you're interested in to be the ones that get synthesized in the lab. Can you see how that increases your throughput? Right? Because you don't need to do the experiment before you get an indication of where likely the target is going to hit. Right? And that's changing a lot. We do this with food science, very interestingly. Right? So where they're trying to come up with new foods, and now they say, okay, let's use machine learning to then figure out coming up with new flavors and all those things, and then you try to predict. You also try to predict actually what customers might think about specific foods before they go to market. On there. People are doing this for protein synthesis in biology. Right? Because they're doing it for drug discovery. Very big field. Where, again, you have to think about the chemical processes you want to go through. You want to synthesize a chemical. That chemical then becomes a drug that has to. So how good is that drug going to be? Very costly if you actually understand the whole drug creation process. So if you can use machine learning to just give you an indication of, again, where you are on the board, where you might hit, it reduces actually your experimentation that ultimately you have to do. And getting those models very accurate actually then increases productivity for a lot of people. And that's why a lot of people use these types of things. And drug discovery right now is one of very hot area in this. Material science is also becoming a very big area of saying, coming up with new materials in there. So you can think about new plastics, new metals, new types of paper, given also the constraints that you might have depending on where you are, right, on the globe, in terms of what input material you might have on there. So it's a very interesting space on there. Thinking about sustainable packaging. So I spent some time I think 2017, with the city of Tshwane's a sanitation department. We just did as a data scientist, you always have to humble yourself in front of other people because they're the experts. You're just there to deal with the data. So we do these things called ride-alongs, right, where it's almost like a journalist. You just go and spend a day with somebody on their job so that you can understand what the data that you see in the spreadsheets, what it actually means in the real world. And we spent time with waste pickers, understanding what was going on there. We were in Oliver Notbosch, seeing the dump trucks going and picking up the rubbish bins, looking at problems where they're having issues with dumping sites, interacting with very, very passionate municipal workers who actually bought PPE for the waste pickers out of their own money. The city doesn't want to recognize waste pickers because then they have to be responsible for them. So almost all municipalities will say, no, waste pickers don't exist, right? But it's very weird because the recycling that's done in South Africa, 90% of it is because of waste pickers. And remember, from the Department of Environmental Protection, Environment, we're closing down landfills in South Africa. And we're supposed to get to a point, I think, where 90% plus of our waste is supposed to be recycled. Right? So recycling has to go up one way or another because we're not going to build new landfills. City of Tshwane, if you live around there, I know it, they've been closing down landfills. So this is a thing that has to be resolved on there. So now if we're thinking about this, is now how can this be supported through the processes that could be done by organizations, right? Not just saying, yes, somebody has to go and build a recycling center, and then we'll do reclaiming and all those things. But then what are these tools that we can actually use within these types of spaces? So one, you can use computer vision. So computer vision here is the same as I said with the imaging. You have a cameras that are looking at things and then using machine learning to do specific things in there. So one, there's some work that goes into identifying actually the types of plastics that are in recyclables. So just imagine now having the waste pickers, instead of them having to spend lots of hours actually picking out the plastics that they know they're going to get some money for, they could just actually be given a wider search space and say, no, as long as you bring a plastic in, we'll weigh it and give you those things, because on the other side, we have conveyor belts that have these cameras that can look and then identify the different types of plastics are there, and then we can then do the next step, do automated sorting with robotics. Right? Because if you can identify what the plastic actually is, it's much easier to get a robot arm to then say, okay, put this here, put this there, put this there, put this there, and then you go through all these different parts of what recycling has to be. Right? At the moment, you have that bottleneck. I've seen, again, as I say, you spend time with with all these waste pickers, the amount of time that it takes to actually sort through everything and then identify, that could then be reduced a lot, and then they can actually help and spend more time actually getting more of these things, not going to the landfill, but then actually going back into into processes to be recycled on there. So this is the work of AMP Robotics. This one is in the US, but there's many companies that are trying to do this as well. I was saying to Ruben earlier, the context here is that yes, this might work very well because that the computer vision system that's there is trained on what American trash looks like. So once you try to take it and say, let me just apply it in South Africa, you might find that its accuracy drops, right? And that tells you the why you keep on having to need in these things, that you must have local talent that can do this work, right? It is not just simply importing systems, because they will lack context. Our packaging looks different. The brands that we have are different. The way that even we have similar brands, the way that we, how the colors we use are different in those things. So if you can't identify that, then this becomes a thing. So you need to have more people doing this work here. Demand forecasting, right? You have very integrated, I think from the first speaker today looking at economics, as you're seeing that and seeing the growth of South Africa in different sectors, what does it actually mean for you as an organization. And so one of the things people do is then try to do demand forecasting that takes into account multiple different variables and then tries to predict for their own production what this might mean going into the future. Right? So you can then look and say, what is 6 months from now going to look like? What is 12 months from now going to look like if we keep to this, given the past history? I have another PhD student. We're doing this for energy, actually. Right? What we're trying to do is not long-term forecasting, but what we call near-casting. Can we take wind and solar radiation from the last 7 days and predict what the next 12 hours are going to be? So you remember that whole argument that no, Eskom doesn't like renewables because you don't really know how much wind you'll have. It mostly doesn't make any sense because we actually do know with near-casting you can predict 12 hours ahead, 24 hours ahead of likely what your wind resource is going to be. So you'll know, given your wind farms, what power is going to come in and what your solar radiation is going to be in the next day. The longer-term ones tend to be climate modelers who do that. So when they look like at 6 months, because you have to then almost like look at these huge physics equations on what's going to happen with the weather over the next 6 months. But the near-casting, meaning what is going to be my wind tomorrow, you can use machine learning for that. Right? And it doesn't mean, even for the other thing, for climate modeling, more and more machine learning is coming in. But right now, the top places for weather prediction are these physics and mathematics and huge supercomputers that try to then predict these types of things. So you can see there in the favor of saying, in doing demand forecasting, looking at your supply chain, supplier selection, making changes on the demand planning, green supply chain management, as you could be assisted then by using machine learning and AI within those spaces. More cheeky on my side, understanding your customer's customer. Right? So I got that little piece of text a few hours ago when I was in Rosebank. I just found it on one of the more popular social media websites. No one wastes packaging more than they will use the hugest box for the smallest items. And then I put this into a large language model that's similar to ChatGPT. This is an open one that we like using. And it says, hey, the sentiment of this statement appears to be very negative, right, on there. Then I asked, like, okay, what's the customer's problem? To this AI chatbot, and it responds and says, hey, the issue with how much packaging this company uses, which they perceive as wasteful and unnecessary. They mentioned that the company tends to use large boxes for small items, which might contribute to excess packaging usage. It is possible that the customer feels frustrated by what they see as poor environmental practices of that company and believes that the company could reduce its impact on the environment if it used less packaging. Right? So that company must have more sustainable packaging methods. Did you see where we started? We just asked the chatbot, what is wrong? Well, like, here's this somebody's talking about this company. What was the issue? And then it was even able to extract all of that. These are, I didn't make up this example. Like, I didn't type. I just asked those two questions only. What is the sentiment? And then what's the problem? Right, so you can see how now even here, machine learning, in this case called natural language processing, can now help analyze your customer's customer and how then that might impact you and the services that you offer on there. So how can the company improve? Which is the next one. And then it puts up a couple of options that can be used there. Reduce the size of the packaging, use recycle or biodegradable, encourage customers to reuse or recycle, invest in alternative delivery methods, conduct regular audits of packaging processes. What does this mean? Here's some work in more AI. This is from a company called InstaDeep. They're based in Tunisia, and they work on this bin packing problem. Right, so you've got a bin, it's the size that it is. You've then got packages that need to be fit into that bin, right? And you need to figure out what is the minimum bins that you need, what's the size that you need on there. This is it's what we call a combinatorial problem. And then what you can then use is build some AI that uses optimization to figure out how to actually fit those things inside the bin, right? So they do it for like the shipping containers. Right, on how to make sure you stack the right things inside the shipping containers. But you can see the same thing is actually supposed to be used for a lot of companies when they actually do things like delivery, on what is actually the size of the box which you use for the product that the customers are ordering. you need to do that bin packing. So instead of just having huge boxes and then you open it and it's like a small thing, where it's taken as being very wasteful. Right, so you can use AI in doing that and this combinatorial optimization part, and then it improves actually your thing, more sustainable, reduces the packaging that ends up in there. And then, as I said, like if you then take care of the whole and make sure that people can recycle, help the people who do the recycling in South Africa, that also makes it much better over time. Right? And these types of things, these opinion mining, you can extend it to different things. So this is some work from a PhD student, Tope. And for example, we were exploring perceptions of South Africans to COVID-19 lockdowns by looking at Twitter or X over the first couple of months in 2020. And it's very interesting because what you can do is you just look and say, hey, can we get all the Twitter data that is in South Africa or these major cities? Can we then build AI tools that then go through understanding the sentiment, and then from that sentiment, we can then try to go in and say, okay, here's how South Africans are feeling. One of the things we could find out is that, yes, at the beginning, the first lockdown, the first few weeks after the lockdown happened, South Africans were very happy, right? We were seeing our government is doing something. COVID is there, it's ravaging people, it's doing something, so yay, positive, right? Honeymoon phase. Then they came for our hot chicken. Right, you couldn't buy the rotisserie chicken at the supermarket anymore, and then things started going downhill. Our opinions or sentiments started becoming more and more negative. The longer the lockdowns went, the more the craziness of these types of things happened, the less people actually had trust in government and what was actually going on during that period. So that we were able to actually check through looking at, for example, Twitter and Facebook and what people were actually saying, and we actually show a graph that does of like, oh, positive, 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 and then starts falling off. And it stays for a long time really down there, right? As the lockdown kept on coming and coming and coming over and there. The other things you can do is provide really for a multilingual world. We tend to think like, everything is moving to this monolingual English world, but can you be doing things to assist some of your suppliers, some of the people who are into by being able to actually interact in their languages and their things. So this is work by master's student Fiskani, and what she's doing is that we're working between Uganda, Kenya, and South Africa to say, can we build knowledge bases for agriculture, for farmers? We can build those knowledge bases in English in lots of different innovative ways, but then allow farmers to almost access like a WhatsApp bot in their language. They can ask a question in their language. Then our system identifies actually which English question answer likely is connected to what that farmer was asking about, and then respond to that farmer also in their language, not in English. Right, so we're building those types of things. We're doing research in that area, and we're hoping, especially at towards the beginning of next year to have some of these systems available. I know a company that does a similar thing for maternal health in Kenya, right, where they allow expectant mothers to be able to interact in their language, asking questions about their pregnancy, and be able to get responses from timely that assist them to make better decisions about their health. On that one, right? So that actually has a huge impact on people on there. So you have to build up these things, these terminology lists, build up the AI that can actually do some of these translations in context to what actually the person was asking within, in their original language. This one here, especially given that we have an election that's coming up next year, we have a lot of people in our lab who also work on misinformation or fake news detection. So here we're looking at multimodal, where you don't just look at what somebody's writing on social media, on WhatsApp, but you also look at the images that they might be sharing with those things, and then being able to predict if it might be suspicious on there. So with the text, you can identify that maybe there's a very emotive language, typically with a lot of misinformation. I think with prior work, we identified people use very emotional language to try and get people to react, right? So that you can press reshare or retweet or whatever on that one. And that's typically connected to misinformation. On the images, people might doctor the image. They might add things inside. There might be context of, this is not even in South Africa. That's important on there. So this is the work of our student Amika, who's working within these areas where we're building these pipelines that use both computer vision and natural language processing on the other sides. And we're showing that by combining them, you actually get much better detection within these, in these areas. But as I said, like, there's this revolution that's going on, and there's parts of it that are going to be very fast, there's parts of it that are going to be slow, and where do we sit as Africans within here? One of the things that I'm always very happy about on the African continent is grassroots AI is actually much further than most private companies, if not all governments in here. What are grassroots AI? These are organizations that work by just communities organizing. They lower barriers to entry. They're typically multidisciplinary by design, inclusive. They address systemic issues, collaborative, independent, holistic, and community focused. So as I said, we co-founded the Deep Learning Indaba. I was one of the co-founders in 2017. And what we wanted to do is we were very concerned that, hey, this AI revolution is here. It's not coming. Like, at that time, people would say, fourth industrial revolution is coming. Like, no. AI has been with us for decades. It's just that it's moved much, much faster. We want Africans to become critical contributors, owners, and shapers of this revolution. We shouldn't just be people who are given, or we are the ones who have to change on that. We have to make sure that we can shape this on there. So we wanted to strengthen African machine learning, and we started this annual meeting or conference for researchers and developers and engineers in AI because we didn't see anything in the market on that. Yes, there's the ones where people will sell you software and all those things, but here we want people to say, no, we're actually building these things ourselves, right? They're not imported, we're building them here. So our first meeting was at VETS. That's why I did my undergrad actually in engineering back in the day. So we went to VETS, 330 people attended. In 2017, we had 700 applications. The next year, we went to Stellenbosch, 650 people attended. We had 1,500 applications to attend this meeting. After that, we went to Nairobi in Kenya, 650 again. We are now at 1,800 applications. Right, showing you just the demand on the continent of people wanting, like, who are working within these areas. Last year, we were in Tunisia. Because of COVID, we scaled down. We didn't know what was going to happen. And then we had 400. 2 weeks ago, we were in Ghana and Accra, 800. Africans who work on cutting-edge AI, whether it's computer vision, natural language processing, health, robotics, those types of things are really on that. So we have the people, especially young people, who work within these areas. And as I said, they're enabled by this thing of thinking about the grassroots. The other thing that's very important on here, that's very different actually even from international conferences, is it's 800 attendees, 45% were women. There's no other AI gathering in the world that has it. And the one is we're intentional about it, and you see it when you're there in terms of how people interact, the kind of skills that they're building, on that part, and making sure that people have access, right? You cannot do it afterwards. It was because we built the community from the beginning to be more representative of who we are as Africans, right? Not to say, no, it's not, we can't get people on there. There's a lot of reasons people are self-selecting. We know this about women. They'll say, I don't think I should apply. I'm not really doing, I don't really fit what this is, who we're looking for. But there's a lot of people who work to say, no, you should apply. There is a community for you within these spaces, and that's how we've been able to do this. Just actually connected to this, I was the program chair of this conference called ICLR. ICLR is probably the #1 AI conference in the world. For the first time in history, a major AI conference, a global one, was held on the African continent. We were there in May. 2019, which is the last year where they had a physical conference, they only had 16 Africans who made it to the conference. The conference typically has 3,000 to 4,000 people. In our 2023 this year, we had 219 Africans. Right? So that shows how the growth of the African AI community has been, but then the important thing is on our own terms, right? With the way that we want to build this community on there. And it requires then these connections between lots of different people, because it's not just the research and development. There also has to be market pull, people who need services, who need AI, who need data science, so that these young people who are working on these things have a place to stay. Right? At the moment, there's a high chance for a lot of countries that we build these AI skills and we're actually building them for other countries. And not even other countries, other continents. Because there's not as much activity within the private sector. Government at the moment, they're not increasing their spending, they're cutting. It's not going to be the place. It's going to be in the private sector of we need these, these types of skills to be used on the continent, right? And it's a huge geopolitical issue at the moment because AI is seen as the future of economies. What do I mean by that? We're even at the point right now where the USA has blocked China from buying GPUs, these graphical processing units, which are used to train modern AI systems. The US has put in sanctions that China can't buy from NVIDIA. NVIDIA is the #1 supplier of these GPUs. Why? Because of AI. The US is trying to curtail China from being able to actually build up their AI. Right? And if you weren't in the field, people don't even know that this is going on. People are thinking, I know about the Ukraine war and all those things, but literally there's an AI war that's happening. And it's so bad, even right now, getting access to these things is very, very hard. Even for our lab, I had to write a 7-point plan for our lab at the university on how we're going to deal with that. Now you can't access GPUs, especially after ChatGPT was released. Everybody's training their models, so it's very hard to get them. I'm ordering probably in the next 2 or 3 weeks, 200,000 to 300,000 rands worth of new computing equipment for our lab, just so that our students can actually continue doing the work that they have to do on there. We're working with some of these big cloud providers and saying, can we get access on there? Even the cloud providers are like, yeah, you just have to get in the back of the line. Because that's how much activity is within these spaces. And grassroots AI has been part of AI internationally, where we've had, as I said, Deep Learning Indaba was 2017. You see other organizations coming along and they keep on spinning out. There's ones in climate, there's ones in robotics, for example, that are coming in, and people being able to work within these spaces. The other thing we know is that whatever got us here to now having this vibrant community is not the thing that is going to take us there in where the next space is. So we need to be able, there's a lot of funding to work on AI, but we can't absorb it now because we don't have enough people, we don't have an ecosystem that can also take advantage completely of this. There's opportunities for students and professionals. We need to blaze our own paths, and we need to have local R&D funding and investment. Right? A lot of the funding that's currently available is coming actually from the West. The Canadians, the Germans, the Swedes, all these people are literally giving money to African states to say, work on AI things. That's not okay, because you then don't shape what people work on. Right? You need to have demand of people saying, these are the things that we're interested in, and that's the thing that then drives. So that requires local R&D investment. It's not going to come from somebody else on that part. And then we also have to think, as I finish off, of this part of the demographics of the African continent. Right? That's on the bottom. So the top left is the world except Africa. That is an age pyramid. So you can see most people there around 40s, 30, 39, 40, that's where your mode is, the most amount of the population. Where it is, if you look at Europe, which is the top right, that population is getting older and older. You're at now 60s, 50s. If you look at the left, that's North Africa. It's already changed. A lot of where the most people are, very young. And then when you look at sub-Saharan Africa, completely different, literally a pyramid. Our population is very young. Right, so we need to grow our economies, we need to grow jobs, we need to grow all those things, because those young people, if they're not doing anything, that is a keg, literally part of a keg. In different places. There's lots of things that are happening at the moment in West Africa, and some of those are driven by very young people who are frustrated. Right, so you have to think about that in the general on there. And you need to, in terms of what you can do, listen, understand how things work in AI, get involved, build networks, edge others, and then we need to, as scientists, be involved in these things. Wrapping up, We collaborate a lot with lots of different people at the university and we're also very thankful for all the funders that we have that fund our work and our research work in doing these things. And yeah, I think I'll stop there. We have 5 minutes if there's any questions that I can take. Hopefully, I did give the context of demystifying work within the areas that impact and the customers and collaborators are, and then what's actually going on the African continent at the moment.